altruistic scheduling in multi-resource clusters. And can you go to the next slide? Motivation. Okay, the first part of the slide, we are going to talk about the motivation and introduction to Carbon. Carbon is a novel scheduling system designed to optimize resource allocation, enhance computational performance, enabling efficient processing and analytic. Basically, the Carbon is a tool that improve performance considerably. When we look at its average performance, operates approximately like 1.59 times faster than his counterpart. But what's even more impressive is when we observe its peak performance. In certain situations, Carbon can be as much as like 7, almost 8 more efficient. This make it exceptional, beneficial, and for a wide range of computing tasks. And can you go to the next slide? Okay, here we have the motivation for altruistic scheduling, and this is some of the key points. Uneven resource usage in traditional scheduling, fairness among user or application, reducing wasted resources. So to go in more details, so basically uneven resource usage in traditional scheduling means in many conventional methods, resources are not always distributed evenly. This means some tasks might receive more attention and resources, while others are left waiting. And when we go to the second key point, fairness among user or application. So that means every task, user or application should be given an equal opportunity to access and utilize the resources. So it's essential to make sure no single task monopolize the resources and everything gets its fair share. When we go to the last point, reducing wasting resources is crucial to maximize the efficiency of the system at every bit or available resources. Let me go to the next slide. Okay, the next slide is what I was mentioning earlier, performance improvement that show how these tools, the Carbon is a tool that improve the performance considerably. Is like 1.59 times and sometimes 7.67 times faster. And can we go to the slide number 6? Okay, here this slide we make a comparison with alternative. So in direct comparison, Carbon consistently outperform alternative scheduling system, ensuring optimal efficiency and resources utilization. Go in details with this slide. I can say Carbon consistently stand out as the superior choices because it's not only ensuring that tasks are endly and more efficient, but it also maximizes the use of available resources. So this means that with Carbon, operations are optimized to get the best result without any waste or unnecessary delays, making it more reliable, choices and between other choices. Can we go to the next slide? Okay. This slide is a trace-driven simulation. Trace-driven simulation validates cabin superior performance, underscoring its effectiveness in real-world computation environments. This means through simulation based on real-world scenario and data, cabin performance has been tested and validated. This test demonstrates that cabin not only meets expectations, but often exceed them, showcasing its effectiveness. So in practical computing environment, where reliability and efficiency are paramount, cabin stands out as a top performing tools. That's confirmed its superior capability and benefit for user. Can we go to the next slide? Okay. This slide can see embrace the future. We can embrace the future with cabins. So cabin represents the pinnacle of computation efficiency, and you guys can join us in harnessing this innovating technology for a future of unparalleled performance. And we can see here like a cabin is like the forefront of making computer tasks run smoothly and efficiently, standing as one of the best in the field. By using this cutting edge technology, we can ensure that our computing needs are met the most effective way possible. So we encourage everyone to embrace the cabin capabilities so together we can step into a future where our computer operations are faster and more reliable than ever before. And we go to the design and main idea, the next slide. So here, this slide talk about the design and main idea. Right here, we have the introduction and we have some of the key points. The definition of multi-resource cluster, complex computing environment with diverse resources like CPU, memory storage, used for various tasks while scheduling fair share of cluster resources. Importance of efficiency. Efficient resource allocation is crucial for maximizing productivity and cost effectiveness. And the last point, introduction to the right here, the next slide, we're going to the key objective. Key objective of the slide, slide number 11, we have maximize resource utilization. So it's one of the primary aims of altruistic scheduling is to make sure that every available resources, whether it's computation power, memory, or any other form of resource, is put its best use. This not only means that resources are not lying idle, but also that they are allocated in such a way that the potential is maximized. Efficient utilization reduces waste and ensure that tasks are complete in a timely manner. When we go here to the improve overall system performance, here they mean by a well-optimized scheduling system can significantly boost performance of the entire system by aligning tasks with available resources in the most effective way. The system can process more tasks in less time, leading to quicker responses and higher throughput. This means that user can expect faster execution of their requests leading to higher user satisfaction and more efficient operation. Last point we want to mention in this particular slide is promote the fairness among users. So basically, altruistic scheduling is not just about efficiency, it's also about fairness. The goal is to ensure that all users, regardless of the demand or the frequency of their requests, have a fair shot at accessing and benefiting from the system resources. This ensures that no single user or group of users monopolize resources. Everyone get a fair share of the system capabilities. Can we go to the next slide? Okay, here, this particular slide is the multi-resource cluster. Here we see the characteristic of the multi-resource cluster, multi-resource to manage diverse workload and application, high demand for scalability, and we have some challenges here is complexity in resource allocation and scheduling. So multi-resource to manage. Here, the multi-resource cluster handle um, different components such as computation power, memory storage, and network bandwidth. So the challenge is ensuring even distribution without overburdening any single resources. And the second part, the diverse workloads and application. So this means like this cluster can cluster different application from data analytic to machine learning, put in priority based on each specific resource need, ensuring efficient operation. And the last point is the high demand scalability. Design for adaptability, multi-resources cluster can expand or contract based on demand, ensuring optimal resource use and cost effectiveness. So when we go to the challenge, complexity in resource allocation and scheduling. So understand resource allocation and scheduling challenges. Resource allocation is like it's basically about assigning computation resource to tasks based on the need. The goal is to maximize performance while minimizing waste. Challenge arises when multiple applications run at the same time, each with a unique demand. So scheduling on the other end determine the order of task execution based on criteria like priority or deadline. Difficulty lie in balancing high priority tasks without neglecting others. So together they form a complex task where every task and resources must fit perfectly to ensure an efficient computing environment. Can we go to the next slide, please? So this slide, we talk about the resource allocation, significance of resource allocation, ensure that resources are used efficiently, prevent resource rotation and bottleneck, traditional methods, mention traditional scheduling technique like before round robin and priority scheduling. And this particular slide, the resource allocation, I can say, is the process of distributing available resources to different tasks to ensure they run efficiently. Also play important role in preventing wasting of resources and ensuring that there are no clashes or slowdown. So it's also known as a contention and bottleneck. So over time, various traditional methods have been developed to handle this distribution, including first in, first out right here, and we have the round robin, and also priority scheduling. So this method dictates the sequence and priority in which access resources, and it makes sure a smooth operation. Can we go to the next slide? Slide number 14. We have the altruistic scheduling overview. So what is altruistic scheduling? A dynamic approach prioritizes underutilized resources, focus on fairness and cooperation among tasks. Altruistic scheduling prioritizes underutilized resources and fairness among tasks, where traditional scheduling methods often focus on predefined priority or fixed time slices. Um, these slides explain like the altruistic scheduling is like a method that emphasizes sharing resources fairly. So it give priority to resource that are less used, aiming for balance and cooperative distribution among tasks. This approach contrasts with traditional method that assign resources based on set priorities or schedule. Can we go to slide 15? Okay, slide 15 is algorithm and technique. So, matrix scheduling algorithm is a fair share based algorithm with fair queue, professional share scheduling, fair share based algorithm, resource allocation based on user defined weights. We have the formula and we have like those key points: weight, fair queue, and professional share scheduling. Basically, we put out this slide algorithm and technique. It means like the fair share based algorithm right here allocate resource according to the importance of the weight. The weight you assign to a user. And here, weight fair queuing is like it's give out resources in line with the importance set comparing to total importance of all user. We have those formula to calculate uh those different algorithm. And when we go to the last part, proportional share scheduling, basically we also have the formula and also distribute resource based on the specific share you decide for a user, considering all user shares. Can we go to the next slide? The benefits of altruistic scheduling. So based off this graph right here, show the benefit, and you can see here it improve resource utilization, fairness in resource allocation, and enhance system performance. So that's some of the benefits, for altruistic scheduling, because it's using resources like we mentioned before over the slide more efficiently. Everything available is put to good use, and ensuring there is no waste, giving each user a tax, a fair share, that no one is left waiting too long or gets more than the due. so leading to like event distribution. As a result of this practice, the overall system operate at its best, and we have faster response and handling more tasks effectively. And this harmony not only ensures smooth operation but also optimize the capability of the system. We go to the next slide. Have some of the challenges here in slide 17. Challenges in altruistic scheduling. There is a complexity in algorithm design, scalability issue in large cluster, ensuring cooperation among tasks. So the the designing altruistic scheduling can be like complicated because it's not easy to make the system. So when you have a it's like when you have a really big group, really big system or group, making grow without problem become a challenge. As getting all the tasks to work together nicely can be tricky. It's like trying to get everyone in a big team to play well together. Those are some of the challenges we have in altruistic scheduling. And the last slide I want to talk about before okay, is the use case of altruistic scheduling. So some of the use case we use altruistic scheduling. We have the cloud computing environment. We have the scientific computing cluster, and we have the data analytic platform. And here you see some of the example while it's important to use altruistic scheduling. We can say like, based off all these scenario, altruistic scheduling can be beneficial in many points, like in cloud computing environment, which refer to a vast network where data and program are stored over the internet instead of computer hard drive. So it helps to manage and distribute tasks effectively among numerous systems. And with scientific computing clusters, researchers require powerful computing system to handle and process complex scientific data. So proper task allocation ensure that every research task receive like adequate resources. When we go to the data analytic platform, so we use altruistic scheduling to analyze and interpret large volume of information. Efficient task scheduling guarantee that data process don't wait too long and that insight are generated promptly. So this is basically some of the importance, the design and main idea of the altruistic scheduling. So the next slide I'm gonna give to Patel to continue.
Yo, my name is Arav Patel. I'll be taking over from here. So the goal of Ultrastic scheduling is to provide a long-term optimization by scheduling leftover resources without affecting performance and efficiency of existing running tasks. There are three major functions of an altruistic scheduler. First is interjob, where scheduler will try to increase the leftover resources while assigning jobs. The second is intrajob, where scheduler determines how much a job should contribute to leftover resources. Third is leftover scheduling, where it will redistribute the leftover resources to jobs that are closest to completion time and maximize it maximizes the efficiency. Uh, so we can demonstrate how altruistic schedule processes when receiving jobs with a small example. Here we have job one with 3 stages and multiple tasks, along with job two with 1 stage and 2 tasks. Upon receiving these jobs, interjob will fairly allocate jobs to maximize the leftover resources by using DRF, domain resource fairness. Uh, then the intrajob will determine how much jobs should contribute to leftover resources. In this case, we can see that traditional scheduler is taking 2.05 completion time units versus 1.5 completion time units by Altruistic scheduler with more leftovers. So we clearly see that completion time is more efficient uh, with the Altruistic scheduler. Then the leftover resources is redistributed to the jobs that is closest to completion time, and it will maximize the efficiency. In this case, we can see altruistic scheduler utilize leftover resources for job two complete and complete it earlier. Implementation details section. So in here, Carbine can be implemented as a pluggable scheduler on Apache Yarn. So that run framework that runs on Yarn can leverage the scheduler. There are two key components required to enable altruistic scheduling. First is local resource management that determines how much resources can be left over from each application. The second is leftover resource management that determines redistribution of leftover resources to other jobs. There are three modifications we have to make in the architecture. The first is RPC mechanism to increase the ask data, data structure, as well as improve protocol between yarn, RM, and TIS AM to transmit the complete resource allocation for a task. So ask default are tasks that must run in order to avoid slowdowns. And ask altruistic are tasks that may run if the job scheduler tries to use all the allocated resources. Another component is T's job manager. It implements intra job functions that performs reverse packing using identify the minimum set of tasks which will be ask default. Also, it computes ask altruistic using default intra-job scheduler in TES, which uses breadth first ordering to schedule a task. We also need to update Yarn Resource Manager to project tasks, resource requests to available capacity. periodically computed the DRF allocation and propagate the corresponding resources allocation on the next heartbeat response to every AM, which is the interjob procedures. This process this process is very similar to Tetris for scheduling task request for task default. So we can go to evaluation section. So to experiment with this scheduler, they have used cluster of 100 bare metal servers and 4 benchmark workloads. Each experiment jobs are randomly chosen, and they run it 3 times, and each of them contains 250 jobs. The whole cluster can run up to 2000 tasks parallel. Also, they use simulator to analyze the performance and store various data while running Carbine. To evaluate the scheduler, they compare the performance, efficiency, and fairness with Tetris, um, DRF, domain resource fairness, and SJF, which is sort job first. So these are observations for offline cases. In fairness, Carbine performs better than Tetris and SJF while matching closely with DRF. In performance, Carbine beats SJF, but Tetris and DRF are way better than it. In efficiency, Carbine performs better than Tetris, but DRF and SJF are way better than it. These are observations for online cases. So in fairness, Carbine again is performing better than Tetris and SJF while matching closely with DRF. In performance, Carbine beats SGF, but Tetris and DRF are way better than it. Um, in efficiency, Carbine performs better than Tetris, but DRF and SGF are way better than it. In terms of completion time, we can notice that Carbine is way quicker than DRF and Tetris in completing a job. So conclusion. In conclusion, we can see that altruistic scheduling can be very beneficial in the long term. We can increase completion time of jobs by utilizing leftover resources. Uh, what makes Carbine stands out is its clever approach of sharing resources along with different tasks and jobs. Um, this shares this sharing idea leads to long-term improvement for everyone using the cluster. Uh, Carbine is also really good at adapting the different situations, like when there is a lot of demand for computer resource or when some tasks are more important than others. Um, it's like having a smart manager for your computer cluster, making sure things are fair and efficient. In a nutshell, Carbine is a practically solution that makes computer cluster uh, work better for everyone. Uh, Finding the right balance between fairness, performance, and efficiency in today's world is complex computing environment. Um, I think that is all. Thanks all for watching. Have a nice day.